So, looking at a quick summary of the paperwork you should have so far for the system realization. You should have your final system block diagram, you should have your inputs, your processes and your outputs labelled within that system block diagram. You should have your final circuit, and your circuit should have all of the components clearly labelled. So if on Circuit Wizard you right click on it, get the properties box up, you can then, if it's a transistor, you can find the correct value for the transistor, which could be a BC639, a BC548, a 2N2222, depends on what it is you've decided you need to use. You need to have the correct values for your resistors, so this one's a 330 ohm to protect these two LEDs. Your diodes, you need to select a specific type of diode. So basically for every single component you should be right clicking and seeing if there is a drop down menu for you to select values for the components. And you should also, if there's a label box, so here you might put in 3-volt motor or 9-volt motor, since this is a 9-volt circuit, 9-volt motor, and you label it using Circuit Wizard and you put your circuit into the document. You then need a final evaluation of the circuit, so you should have your points to be tested. This should be taken straight from your specification table that you did pages and pages back. You should be saying how you are going to test them, and this is testing the actual circuit. So far you've tested the system block diagrams, but on this one you're testing the actual circuit diagram to make sure it works properly. So you're saying how you're going to test it. There's an example here, use of the data sheet. That on Circuit Wizard you can't actually say I want a LED that is this number of millicandela, which is what MCD stands for. So you would just say, actually, no, you can't test that on Circuit Wizard. I'm going to use the data sheet for that, so I can't give you any results here. This one is to do with the actual shape and design of the buggy, not the circuit itself. So I've said, can't test it, it's not a circuit thing, so it's not applicable. So you should have all of your specification points down this column, how you're going to test every point, or why you can't test it, and then the results of the test. And please remember, the main thing they want to know is what you need is your voltage signal out of block A, and what you need for your voltage signal into block B, and how does block A control the block B, block C, block D, and so on. You then need a short conclusion. Hopefully you'll just say, yay, everything's working, I'm going ahead with this, and then you move on to your system realization planning. Now, you've already should have looked at videos where you've gone through the whole breadboard planning, where you've got your key to the breadboard and you've sat and you've drawn it out on a piece of paper, and then you've scanned it into the document. You might have had a few attempts, or you've done that stage and then you've said, right, I'm doing my PCB, and you've started to go through and you've followed the stages in the example on the video of how to produce the PCB paperwork and the planning for the PCB. So that should all be in your folder or in the file by now. And the last thing in this section is your risk assessment. And I know how stupid it seems to say I'm doing a risk assessment for breadboarding, but you still need to do it. Obviously there's a lot more stages if you're doing it for making a PCB, but you should have the stage of manufacture, you should have the potential hazard, who's at risk, and what the control measure is for each of the different possible hazards. And when it's breadboarding, it's things like making sure that you've got safety glasses on in case any of the components blow up. So if you put too much current through an LED, bang, it can either go up in flames, melt, or physically pop the end off it, which is then going to come flying up towards your face, so you need safety glasses on. Making sure that you don't put too high a voltage through things so it sets them on fire. Making sure that when you're trimming legs down, you're not cutting it so that the legs, when the cutter goes through, the ends of the legs go flying towards your eyes. Those types of things. And you need to have those. I've only come up with about 4 different things for a breadboard risk assessment. PCB manufacture, loads more, all to do with the use of acids and chemicals and everything else. So when you've completed that, you then build your circuit. Now you don't need to take photographs of the stages of building the circuit, but you do need photographs at the end. So your completed circuit, you should have a series of clear photographs. So this is off my line following buggy. Some little darling snapped off one of my motors. That's been fixed since then, but it was easier to actually photograph it with it off. So I've done a general photograph with everything. I've done then a close-up of the breadboard. Do need to be careful because they have to be able to clearly see everything on the breadboard. I've got a little written piece of text here about what I'm looking at within the breadboards and what I did while I was manufacturing it to ensure that it was high quality. I've then done a few close-ups, so I've said, right, here's my motor, and I've put a note here that to make it easier, I soldered the wires onto my motor rather than using crocodile clips, and then I put a little bit of heat shrink on to make sure it was neat and well presented. That I manufactured little sensor units using strip boards, soldering, etc. And that where I wanted to put the ribbon cable in, I put them onto pin connectors so it was easier to fit it in the breadboard. So all of that is explained here. So I've got multiple pictures showing my final make and explanations of how I made sure it was good quality. System testing. I forgot to take photographs. Basically, there should be a photograph of your computer, your Pico board, your breadboards, everything wired up, photographs of the whole system, and another one with you with an ammeter on your circuit so you can show that you're measuring the current that is drawn by your circuit. Those two pictures should be there. I'm at home, not at work, so I can't add the pictures in because I can't take the pictures because the stuff's all at work. Right, next bit, system testing. This is what you're doing with the picoscope. Now, I've made two videos, one showing you how you connect up the picoscope and one showing you how to take the readings from the picoscope and put them into your document. So we shall pause it there and we'll pick up from this stage in another video.